Hello to all the viewers of DIVI Group's Boiler Experience Sharing channel. Today, I would like to present the working principle of the 2-drum water tube biomass fluidized bed boiler designed by DIVI Boiler under DIVI Group. First, let me highlight some types of fuel that are highly efficient for this fluidized bed boiler technology, such as rice husk, chopped wood, sawdust, cashew nut shells, and chopped peanut waste, among others. In addition, the fluidized bed boiler can also use fossil fuels like coal. Initially, the fuel is loaded into the storage hopper of the conveyor, typically located in the fuel storage warehouse. From there, the conveyor transports the fuel to the fuel intermediate hopper of the boiler before being fed into the combustion chamber. At the fuel intermediate hopper, the fuel is directed into the combustion chamber through the incline of the hopper. Air from the fuel feeding fan helps transport the fuel into the boiler faster and prevents backfire. Inside the combustion chamber, the fuel is evenly distributed over the grate surface. And with the combination of oxygen and high temperature, the fuel undergoes continuous combustion. Here, the hot flue gas rises to the steam generating pipes above. The secondary air fan supplies additional oxygen to support combustion, reducing the emission of CO into the environment. The steam generating pipes above the combustion chamber, containing water inside, are heated by the thermal energy generated from the fuel combustion process. At this point, approximately 60% of the steam is produced through radiative heat exchange. After radiative heat exchange within the steam generating pipes, the hot flue gas flows into the convective heat exchange unit, which is structured with 2 drums, one on top and one below. Water flows inside the pipes, while the flue gas moves outside the pipes. The water absorbs heat from the hot flue gas through the pipes, transforming into steam, which then gathers in the upper drum. The steam is delivered to the end-use unit via the primary steam valve and the piping system. At this stage, approximately 40% of the steam is generated through convective heat exchange within the convective heat exchange unit. The large particle ash collection hopper is located at the bottom and removes ash particles of larger size through rotary valves. After heat exchange within the boiler body, the flue gas still contains residual heat at a temperature of 250 degrees Celsius to 300 degrees Celsius. Therefore, the flue gas is further directed to the economizer to utilize the remaining heat for preheating the feed water before it is supplied to the boiler. The economizer has a structure where the flue gas flows outside the pipes and water flows inside. Here, the water is heated up to 150 degrees Celsius, significantly improving the efficiency of the fluidized bed boiler. The flue gas, now at a temperature of approximately 180 degrees Celsius to 200 degrees Celsius, continues to the air preheater, where it heats the air before it is supplied to the combustion chamber, further enhancing the fuel combustion process. The air preheater is designed with flue gas flowing outside the pipes and air flowing inside. Here, the air is heated to nearly 100 degrees Celsius, which significantly improves the complete combustion of the fuel and increases the fluidized bed boiler's efficiency to 89%. The large particle ash collection hopper below the air preheater gathers some of the larger ash particles from the flue gas, which are removed via a rotary valve. This is the primary air fan for the combustion process. The air is blown through the air preheater and guided into the boiler to support combustion. After the flue gas's thermal energy has been thoroughly utilized, it is directed to the cyclone dust separator system to recover most of the larger ash particles. The cyclone dust separator system consists of multiple centrifugal dust separation components designed according to British standards. Ash falls into the hopper and is removed via a rotary valve. while the remaining fine dust particles in the flue gas are fully captured by the high-efficiency bag filter system. The high-efficiency bag filter system comprises many internal filter bags. Flue gas passes through the filter bags, where dust is trapped and adheres to the bag's surface. When the dust layer becomes sufficiently thick, compressed air is injected inside the bags to dislodge the dust particles, which fall into the large particle ash collection hopper below. The ash is then removed through the rotary valve system. All ash collected at various stages is consolidated using a screw conveyor system and transported to the ash storage area. The induced draft fan facilitates the movement of flue gas from the combustion chamber through the convective heat exchangers and the subsequent heat recovery and dust treatment devices. The flue gas dust treatment tank collects any remaining ash in the flue gas using a Venturi water spray scrubber. Finally, clean flue gas is released into the environment via the chimney system. The deaerator tank removes oxygen from the feed water, reducing corrosion of the steel components within the boiler due to oxidation. The feedwater storage tank reserves a sufficient amount of water, allowing the boiler to operate continuously for a minimum of 1 hour. The high-pressure water pump system continuously supplies water from the feedwater storage tank to the boiler based on the water level in the drum and the plant steam demand. Before entering the boiler, the water must meet quality standards through a softener system. The steam header gathers steam from multiple sources before distributing it to various end-use units. Additionally, the steam header plays an essential role in drying the steam before it is used in production processes. The entire electrical control system is housed in a sealed room equipped with air conditioning to ensure the durability and stability of the equipment. Only 1 to 2 operators are needed to manage the entire system during each shift. This concludes the explanation of the operating principle of a 2-drum water tube biomass fluidized bed boiler designed, manufactured, and installed by DIVI Boiler. This fluidized bed boiler technology has been implemented in many projects across Vietnam. The biomass fluidized bed boiler technology, designed by DIVI Boiler, helps customers meet the standards set by the bilateral and multilateral agreements Vietnam has signed. We hope this video helps the audience understand more about the 2-drum water tube biomass fluidized bed boiler technology. We look forward to receiving your feedback and suggestions to further improve our products. Thank you.